It's the middle of the night. You're asleep. Something large enough to open you like a can of soup is standing 3 meters away, and then it turns around and walks back into the dark. The obvious answer is fire, or smell, or noise. But those explanations are incomplete, and what's actually happening goes much deeper into predator neurology, millions of years of evolutionary memory, and something you've been doing in your sleep your entire life without knowing it. Fire keeps predators at distance, and noise signals alertness. But field researchers tracking large carnivore behavior in sub-Saharan Africa and South Asia have documented something that doesn't fit that tidy explanation. Predators regularly withdraw from sleeping humans in situations where there is no fire, no noise, and no visible group. The human is simply there, alone, motionless, apparently unconscious, and the predator still leaves. So fire isn't the full story, not even close. What's actually happening starts with a concept called neophobia, the hardwired tendency in predators to treat ambiguous or unfamiliar stimuli as dangerous until proven otherwise. It's essentially the predator's version of if in doubt, don't. Every large carnivore runs a continuous threat assessment calculation. Does this thing cost me more than it gives me? Prey animals produce clean, readable signals, specific scent profiles, predictable movement patterns, recognizable flight responses. A sleeping human produces none of those. The signal is confusing, and in the neurological logic of a lion or a leopard, a confusing signal is not a green light. It's a warning. Think about what that looks like from the predator's perspective for a moment. Here is an animal that isn't running, isn't making prey sounds, doesn't smell like anything familiar, and yet is clearly alive. It's the biological equivalent of finding a suspicious package and deciding, you know what, probably fine. Most predators, sensibly, do not make that call. But neophobia alone still doesn't explain the depth of the avoidance, because there's a second layer underneath it, and this one is older and more severe. Humans are not just unfamiliar to predators. Humans are, in the evolutionary record, catastrophic. The archaeological evidence from the late Pleistocene, roughly 50,000 to 10,000 years ago, documents wave after wave of megafauna extinction on every continent where modern humans arrived. In North America, something in the range of 35 large mammal genera disappeared within a few thousand years of human arrival. In Australia, the pattern was even sharper. Researchers examining sites across both continents have found the timing correlates tightly with human expansion, not with climate shifts alone. The predators alive today are, in a very literal sense, the descendants of animals that survived by being extremely careful around the species, that showed up with coordinated hunting strategies and didn't stop. That caution didn't disappear when the hunting stopped. It got encoded. Behavior that kept an animal alive long enough to reproduce gets passed forward, not as a conscious memory, but as a neurological bias, a low-level reluctance that doesn't require the animal to have ever seen a human hunter to feel it. Evolution doesn't need the individual to understand the lesson. It just needs the lesson to stick, which brings you back to that motionless human, 3 meters away, apparently helpless. The predator isn't seeing easy prey. It's running an ancient calculation that has historically catastrophic baked into one side of the ledger. The sleeping human looks vulnerable, but the species attached to that sleeping human has a track record that predator neurology hasn't forgotten, even if the individual animal has never personally had a reason to remember it. And here's what makes this genuinely strange. That's still not the complete answer, because what we've established so far, neophobia, evolutionary fear memory, the megafauna record, explains why predators are cautious around humans in general. It doesn't fully explain why a sleeping, motionless, apparently helpless human specifically triggers the same response. Something is still being broadcast. You're just not awake to know you're doing it. So here's a quick one. Knowing that predators have historically catastrophic burned into their neurology around us, do you think that fear would hold if humans had never gone extinct level hunting? Yes or no? Drop your answer in the comments below. Now, here's the part that gets even stranger, because something is still being broadcast from that sleeping body, and you have no idea you're doing it. When you sleep, you feel like you disappear. You go quiet, you go still, you go dark. But from a predator's sensory perspective, you become louder. Not audibly, chemically. Human body chemistry shifts during sleep in ways that are measurable and, to a carnivore's olfactory system, deeply unusual. Your metabolic rate drops, your body temperature regulation changes, and the compound profile of what you're emitting through your skin and breath shifts into a signature that doesn't match any prey animal's resting state. Prey animals, when they sleep, produce scent profiles that predators have spent millions of years cataloging, familiar, readable, filed under food. A sleeping human produces something different, not threatening in an obvious way, just wrong. And in the threat assessment logic we established in the last beat, wrong is not an invitation, it's a flag. Then add the acoustic layer. A sleeping human isn't silent either. Breathing patterns, micro movements, the low-frequency ambient hum of a body in deep rest, these differ from prey animal sleep in ways that predator auditory systems are sensitive enough to detect. Prey animals sleep lightly and erratically because they have to. Their rest is interrupted constantly by their own nervous systems keeping watch. A human in deep sleep produces a steadier, lower frequency sound profile, one that, to a predator running pattern recognition, doesn't match the template for vulnerable prey. It matches something else, something it can't quite categorize. And again, uncategorizable is not the same as safe. Now layer in the group dimension, because this is where the calculation gets genuinely strange for the predator. In evolutionary terms, you almost never slept alone. For the vast majority of human history, the stretch of time that shaped predator behavior around us, humans slept in groups, clustered around fire, pressed together for warmth, surrounded by others who would wake and respond. A predator approaching a single sleeping human was, in the neural math it inherited, approaching a group. With all the coordinated, tool-using, tactically sophisticated retaliation that implied. The solo sleeper wasn't registered as a solo target. It was registered as the visible edge of something much larger and much more dangerous. Which brings us to the Tsavo man-eaters of 1898, and why they matter here as the exception that confirms everything. 2 manaless male lions in Kenya killed and partially consumed at least 35 humans over 9 months, dragging victims from their tents at night along the Tsavo River during construction of the Uganda Railway. This is one of the most documented cases of large predators systematically targeting sleeping humans in recorded history. And when you look at what conditions had broken down, the picture snaps into focus. One leading explanation is that the lions were simply hungry because much of their normal prey had been wiped out by rinderpest. They may also have developed a familiarity with human remains through scavenging corpses left behind by caravans that traveled through Tsavo for centuries. The workers, meanwhile, were isolated in nighttime camps, sleeping in tents, separated from one another, in small dispersed groups, without the coordinated defensive presence that predator neurology treats as a hard stop. Every layer of the normal deterrent system had degraded simultaneously. Prey scarcity overrode caution. Familiarity with human remains had eroded the wrong signal response, and the group coherence that usually registers as a warning was fractured across scattered, isolated tents. The lions didn't overcome the system. The system had simply stopped running, which tells you exactly how load-bearing each layer normally is. You are currently sleeping in a house, in a city or a suburb, or somewhere that hasn't had a large predator within striking range in decades, possibly centuries. And yet tonight, when you go to sleep, your body will run every single one of these systems anyway. Your chemistry will shift into that uncategorizable signature. Your breathing will settle into that low-frequency profile. Your nervous system will maintain whatever residual group signaling it can manage, even in an empty room. The ancient armor doesn't check whether there's anything outside that needs stopping. It just runs. The answer to the original question, why does something large enough to kill you turn around and walk away, is not one thing. It's a stack. It's evolutionary fear memory written into predator neurology over tens of thousands of years. It's neophobia treating your unfamiliar signal as a warning rather than an opportunity. It's the chemical broadcast your sleeping body produces without your knowledge or consent. It's the ghost of a group that isn't there anymore, but that predator threat assessment can still sense the shape of. And it's the accumulated weight of a species' track record so catastrophic that the caution it generated outlasted the hunters, outlasted the megafauna, and outlasted every ecosystem that originally produced it. You are, right now, walking around in a body that apex predators are neurologically reluctant to approach, and you have done absolutely nothing to earn that. Your ancestors did it for you, the hard way, over an almost incomprehensible stretch of time. The least you can do is appreciate how strange it is that you're still carrying the armor. Subscribe if you want more like this, and watch the